This is the first video in the chapter on linear equations and solving linear equations. So we're going to look first at solving linear equations by just combining like terms. So if you look at the top, there's a definition. It says an equation that is written in the form of ax plus b equals c, where a, b, and c are just numbers. So in other words, there's a variable and then there's other numbers. It is called a linear equation in one variable. Later you'll be learning about linear equations in two variables, an x and a y, but this just has an x. So let's look at how we solve a linear equation in one variable. The first property that we're going to look at is called the addition property for solving equations, and basically what it says is you can add the same number or subtract the same number from both sides of an equation without changing the solution of the equation. So you want to think of an equation as a balance, like this picture that is here, and the equal sign is right there on that balance. So in this particular case, 1, 2, 3, 4, 5, 6, I have a weight on the 6th, and then I have a weight on the 2 and the 4. So even though the two sides look different, then everyone knows that they are both the same. They're both worth 6 and they are balanced. Well, if I were to add another weight to one side, say right here, I would have to add that same weight to the other side to keep it balanced. So that's what the addition and subtraction property says. So let's look at an example here, and I'll show you how it works. Our goal in solving an equation is get our last line to say x equals, or whatever the variable is, and then have a number there. Well, the one that we start with has a subtracted 2 in the way of it being just x equals. So to undo that subtraction of 2 and get the x by itself, which is our goal, this is our goal, to get the x by itself, we are going to add a 2. If you add it to the left-hand side, though, you must add it to the right. And when I talk about sides, I am talking about down across that equal sign. There's an equal sign here. This is the left, this is the right. Those are the two sides. So when I do that, a negative 2 and a positive 2 just make a 0. And the only thing that's left is x. On this side, I have a negative 1 and a positive 2, which is a positive 1. So we did get our equation into the form of x equals 1 by adding the same thing to both sides. Now, how did we know that we needed to add and not subtract? Because it originally, let me rewrite it. Originally, a 2 had been subtracted, or there was a negative 2. So to undo that, we do the opposite, which is positive 2. All right, let's look at the next one. Here is our variable. This time it's not an x, it's an n. That's okay, we still want to get it by itself. What's been done to it? It has a positive 1 beside it. How do we undo that? With a negative 1 right underneath it. But as our balance tells us, if you put something on one side, then you have to put the same something on the other side. So if I put a negative 1 here, I have to put a negative 1 here. Negative 8 and negative 1 make negative 9. Bring down your equal sign. A positive 1 and a negative 1, they make a 0. They zero out. And you end up with just the variable equal to negative 9. Now, by the way, when you get your solution to a linear equation, it's very easy to take the answer and put it back in where the variable was to check. For example, it said negative 8 equals n plus 1. If I take out that n and I put a negative 9 in its place and I see if it's a true statement, it is true. It does check. So you can check your answers in a linear equation at any time. All right, along with the addition property, which means add or subtract, we have a multiplication property, which means multiply or divide. And what it says is both sides of an equation may be multiplied or divided by the same non-zero number without changing the solution of the equation. And that should say sides, not side. So in this case, we have negative 5x equals 15. We go and we find our x. What's been done to it? It was multiplied by negative 5. What undoes multiplication? Division by the same thing. We divide by the same thing, not by the opposite. We did the opposite up here with add and subtract because adding and subtracting are opposites. But here, to undo multiplication, we divide by the same thing. Why? Because negative 5 divided by negative 5 makes a big positive 1. And that's what we want, 1x. And then 15 divided by negative 5 is negative 3. And you have x equals negative 3. And we did it by undoing what had been done to that variable. Here we have negative 12x equals negative 36. What's been done to the variable? It was multiplied by negative 12. We undo that by dividing by negative 12. Divide by negative 12 and we get x equals negative divided by negative is a positive, and we end up with a positive 3. Notice negative 12 over negative 12 on this side made a 1. And over here we actually do the division. So it's a little different than when you add or subtract, but it's still the same idea of undoing what has been done. Let's look at this one. Here's our variable. What's been done? It was divided by 3. How do you undo division? You multiply by the same number. So I'm going to multiply this side by 3, or 3 over 1. Multiply this side by 3. These 3's cross cancel, and I have x equals negative 2 times 3 is negative 6. So let's take a second. The inverse, let's talk about inverse operations, or what undoes. So the inverse of subtraction, how do you undo it? You add the same number. How do you undo addition? You subtract the same number. How do you undo multiplication? You divide by the same number. And how do you undo division? You multiply by the same number. And that's what we did on this one. All right, let's look at this last one on the front page. This one, I see the variable has been multiplied by 2 and divided by 5. Well, you want to get rid of that divide by first. So how do we undo division? We multiply. So I'm going to multiply this side by 5, or 5 over 1. Multiply this side by 5. These 5's cross cancel, and I'm left with 2x equals 4 times 5 is 20. Now this one is different because we're not finished. There's another step. The variable here is still not isolated. It's now been multiplied by 2, so we undo that by dividing by 2. That makes a 1, and I get x equals 10. Okay? Let's try some more, and you're going to see on this back side, you're going to see a little summary statement of the steps that you take when you solve a linear equation in one variable. Now, some of these we're not ready to do yet. It says, first off, you would get rid of fractions. Well, we're not going to have any. Then you distribute. We're not doing that yet, but we're starting right here. We're going to combine like terms. Then we're going to get variables equal to numbers, which is what we were just doing on the front. And then finally, we're going to divide at the end. So let me try one, show you what I'm talking about. So we look at example 7. We have y plus 8 equals 3 minus 7. Our first step in these 3 that we are doing so far is to combine like terms. Well, I see some like terms there. So y and 8 are not like terms, but 3 take away 7. Those are like terms. A 3 and a 7, that makes a negative 4. Now I'm back to a problem like on the front, where my next goal is to get the variable isolated equal to numbers on the other side. Well, here's the variable. It had an 8 added, so I subtract an 8. That makes a 0, and I end up with y equals negative 12. 12. You're going to have to be sure you know those rules of adding and subtracting integers. I didn't need to divide on this one because there wasn't a coefficient in front of the y. There wasn't a number in front of the y. It was already a 1, so we were finished. Let's look at the next one. We have like terms on the left-hand side. -2 and +2 makes 0. On the other side, I have a -4b and a +5b. That makes a +1b. And then I still have a -6 right there. So I combined my like terms. I'm now ready for the next step, which is to get the variable by itself on one side and all the numbers on the other. So to get rid of this -6, we do +6 on both sides. And I end up with b equals 6. And once again, I don't have to do this last step of divide because I already have a 1 in front of the b. You're going to see one in a minute where you have to divide, so you'll understand how that works. Number 9, combine like terms first. Always combine like terms, all right, before you start doing anything else. So 2r take away r is 1r. 5 take away 10 is -5. And because that's a 1, we're done. That's all there was necessary to do on that one. The variable was already isolated. All right, let's look at this one. Like terms, 7w minus 14w is -7w equals, I'm going to do the positives first. 1 plus 49 is 50, and 50 take away 50 is 0. 0 is a number, so don't think you're finished. You're not finished. So we have combined like terms, so we did that. Variables equal to numbers, that's supposed to be a v. The variables are equal to numbers. That's done. Now we do have to divide. And what you divide by is the number that was multiplied times the variable. We undo the multiplication by dividing by -7. Notice, it's not -7 plus w. A 7 wasn't subtracted. It was multiplied. So to undo it, I have to divide. That makes a 1. 0 divided by anything is 0, and I have an answer of w equals 0. 0 is a number, so that is an answer. Number 11, we have 2k minus 2 equals 5k minus 11. This one's different. If you look on the left-hand side, those are not like terms. If you look on the right-hand side, those are not like terms. So in my list of things to do, combine like terms, get variables equal to numbers, and divide, there's no like terms to combine. But I now need to get my variables on one side. Well, I notice that the variables are on both sides. So how do I get them together? Well, they're both positive, so I could either subtract a 5k or I could subtract a 2k. I'm going to choose to subtract a 2k. See if you can figure out why. It wouldn't be wrong to do it the other way, but that's what I'm going to do. That makes a 0. What's left here is a -2. 5k take away 2k is 3k minus 11. So now I have the variables together, but the numbers are not. The variables are on the right, so all the numbers need to go to the left. So how do I undo -11? +11. That makes a 0. So 3k, -2 and +11 is +9. And so now I have done that step where I have variables on one side and numbers on the other. Last step is to divide. So we're going to divide by 3 because that's the coefficient. It's what the variable got multiplied by. 3 over 3 makes a 1. And I have k equals 9 divided by 3 is 3. So that one had all the steps in it. Let's look at this last one. Here's your equal sign. Here's your left. Here's your right. Are there any like terms on the left? Yes. 3m and 2m makes 5m plus 8. Are these alike? No, so leave them. So I did the combine like terms. Now I need to get the variables together. Well, they're not. They're on both sides. So I am going to choose to subtract a 4m. Again, think about why, because I could have subtracted a 5m. 5m take away 4m is 1m plus 8. I bring my plus 8 down. Bring down your equals 7. So the variables are together. Now I have to get the numbers on the other side. So to undo that plus 8, I do minus 8. And I get m equals -1. Do I need to divide? No, because there's nothing that the m has been multiplied by other than a 1. So you have it finished. There are some problems here to work on your own. You need to go ahead and do those, and then we will talk about those in class, and I'll answer questions there.